adding this one to it.
You actually did 4 as well.
I said 3 and 4. Did I? Sorry.
Sorry.
The first time I said 3 and 4, but that time I said 2 and 3. Sorry. Do you have number 3 and number 4 on a piece of paper? We're going to add number 5, number 6, number 7, things like that to it. Halfway point, this was when they're asking for, find the coordinates of the point halfway between -5, 8 and -8 and 0, 4. What are they asking for?
Midpoint.
So do you remember the midpoint?
Average of the x's and average of the
So
y's.
midpoint formula is x plus x over 2, y plus y over 2. Average of the x's, average of the y's. So what do we get? -5 plus 0 is -5. -8 plus sorry, that's not -4. -8 plus 4 is -4 over 2. I need to reduce that one a little bit. So maybe -5 halves and -2. Does that make sense?
Yes.
We look at it on a coordinate plane. We're back in the third quadrant, -5, -8 to 0, 4. I think that makes sense. So 2.5, if you would rather write it as 2.5. You could have written it like that, 5 halves. Are we good on the midpoint formula? Number 6 is one we just did in this lesson. Number we did was 2.4. Write 7.3 as a power of the base 10. 7.3 as a power of base 10. So 7.3 as, so maybe we're going to is 10 raised to what power? Or x, it doesn't matter. How are we solving for y? We could look like it's an L. So I personally see this n equals BL. And what do we do with logs? Can we solve for the exponent?
Yes.
Yes. I think that would be L equals log little b log base b. So if I take this and I want to solve y equals, this will be helpful, really, really helpful when we have variables in our exponents that we have to solve for. When we want to pull them down, we can always use log. So y equals log base what? Bless you. Log base 10 of 7.3. So what is the y? Well, what is log base 10? It was in your calculator, right?
No. What's the it's like INC?
What's the power?
I'll find
Which
it.
one's power? Which one is it?
Uh,
So we're trying to solve for this y. This is the power. It's an exponent. So if you plug in log, I still have my calculator up here. Whoop. So if I just simply plug in log, and it already has a base 10, 7.3, we have that number. So it's 0.863322860. Do I want all those digits? No. Ooh, that usually doesn't happen. It went away. I don't remember those numbers.
8.63.
0.863? Okay. I don't remember. All I really remember was 86. Okay. So if we want 7.3 is a power. We've solved for the y, so 7.3 really is 10 raised to this decimal number. So try that in your calculator. It's 10 raised. Okay. So if I say 10 raised to this decimal point 863, is that 7.3? Yes. Okay. So when it says write 7.3 as a power, or whatever, what did it say? Words. Write 7.3 as a power of a base 10. So 10 is my base. Okay. Could we write the second part of that one with a base of E? So instead of a 10 there, could we write it with an E? Yes. Let me scroll just a little. So, could we do 7.3 equals E raised to what? This is the B part. So that was A, this is B. 7.3 equals E raised to the what? To the X. So how can you solve for X? X equals what? Log base E of 7.3. What did we talk about log base E? What is that? It's the ln. So really, this is natural log. It's an L. It's natural log. So I plug in natural log of 7.3.
Where is it?
It's right below the log button. Yeah. Log 7. You get 1.987. It's gonna go away. It's 1.987. So could we write? Our answer to B is 7.3 equals E raised to the 1.987. Plug that in your calculator. The E button is the second and then the natural log. Okay, so it's that same button right there of 1.987. And what do we get? 7.29. That's your 7.3. Okay. Do number 6. Number 7. Another log button, a log question. If 3 raised to the y equals 4, if 3 raised to the y equals 4, then y equals what?
Log base 3.
And that was just rearranging.
Oh,
Yes.
we don't have to solve it.
You're going to solve it. You're done. Oh, it was even a multiple choice.
Hey.
Then y equals, it's the second one. But obviously they're going to give you both pieces. To say, or to make you second guess which one goes on the bottom, the 3 or the 4. Okay? More problem. Can you simplify this big, long, wonderful thing? Y cubed. Y to the 3/4 minus 2 z squared. Why in the world do they do things like this? z's have lines through them, so if it's not, it's a 2. Happy that at least in all those exponents, they're just numbers, there's no variables. That's nice. It's kind of silly what they did. It's testing, do you know what to do when you're multiplying with the same base? So I personally would simplify, what's 3/4 minus 2? -5/4 or -1 1/4. Same numbers. So I've got, this is -5/4. What about 3 minus 2 divided by 3? It should simply be 1/3, right? So when we're multiplying, what do we do with our exponents? We add them. So when we're multiplying exponents here at the top, we're adding, when we're multiplying the same base, we add our exponents. So we have 3 plus -5/4. What do we do when we're dividing? You subtract. So can I simply subtract 1/3? That's y raised to all of this. And then you just have to simplify. Adding and subtracting fractions. If you want to go do common denominators for everything, what would you do? Probably gonna do a 12. 36/12 is 3 minus 15/12 is 5/4, right? Am I doing this correctly? 4/12 is a 1/3. So 36 minus 15, I think is 21. Do you think it's 21 also? Minus 4, 17. So we have a y equals, not a y equals, y and 17/12. Now what about z? I'm going to take, nope, that's not a good line. Let's take the z's and do those. It's a 2. I'm going to go ahead, 3 minus 2 is a 1/6. So all I'm doing is subtracting or dividing, so I'm going to subtract the exponents. So it's a z raised to the 2 minus 1/6. Oh, that one's so much easier. 11 over 6. So if you did common denominators, you did 12/6 minus 1/6. So you have a z raised to the 11/6. And you have an answer. That's going back for a while. We haven't seen those in a while, but they will come up again and again. Alright, good. We're back to something that was better. I like number 9, 10, and 11 a lot better. More recent work. Find both a symbolic representation and a numerical approximation for x when. So what does it mean when they want a symbolic representation for what x equals? The logs. And then when they want a numerical approximation, what do they want you to do? Plug it in your calculator. So they want both of those. So if you have 10 raised to the x equals 3, what does x equal?
Log base.
Okay, so that's the first piece it wants. And then it wants x is approximately, what did you say? 4/7. So it's just plugging that in your calculator. You want both of them. B is asking, it's an E. B is E raised to the X equals 5. Until they show us how to do it by hand, you won't have to do anything. They don't give you a log base 3 that you have to do. That last one 3 was 4. They didn't ask for numerical calculations. They taught you how to do it. They will teach you how to do it. I promise. You're welcome. And then this one. So what is x equal to? Log E of 5, which we know we plug this in our calculator with the ln of 5. So x is approximately 1.60943, etc., etc., etc. Okay. Yeah. So those you should be able to just plug in with those numbers. 10. We did some of these problems. There's always room for more. Log base 3 of 27 equals 2b plus 1. Can you solve for b? We're rearranging just like we just did. What does your equation look like? 3, 2, 2b. So where's 3 and the 2b plus 1? So it's an exponent. 3 raised to the 2b plus 1 equals what? 27. Yes. Now, what is going through your brain?
27 equals 3 raised to.
Can we rewrite this 27 as an exponent with a base 3? Yeah. It's not always the first thing that goes through my brain. So if you can rewrite, if they can't give you something right now for you to solve for b if they don't have the same base. So you're going to look, can I rewrite this with the same base? Yeah. Because if not, if you've got a calculator and you can plug in log base 3 of 27, that's a number. And you can simply subtract 1 from both sides, divide by 2, you get an answer. No, that's a way to do it, but they haven't taught you how to do this. They haven't taught the people who can't put it in their calculator. When you can't put this in your calculator, you don't have a number. You don't know how to do it. My old calculators, this poor thing has no clue how to do that. Okay? Now, eventually they're going to teach us, but right now, I promise we'll get the same answer.
A quick reminder that Grand Canyon University will be in the library during lunch today, and they are also providing lunch. So go to the library if you're interested.
If they have the same base, set the exponents equal to each other. So you can do 2b plus 1 equals 3. And you're going to subtract 1, and so 2b equals 2, b equals 1. And that's what you got also, Chris, wasn't it? By plugging that number into your calculator, even though they all can't do it. Okay? Eventually.
The 13th. And it's a full moon.
Oh, okay. He said something completely different, and you guys heard it's Friday the 13th.
Friday.
You know, it's gonna be
And it's the full moon. It hasn't happened in 20 something
and the
years.
next time it's
So
gonna
it's
happen.
Friday the 13th and the full moon, and it's a special moon.
Oh, so will something happen today?
I've tried to get my child to watch all the horror movies tonight, even though I know I won't do it.
No wonder I feel so bad.
No. Alright, can we do number 11?
Yes.
Number 11, solve for x. Log x raised.
Friday. Why Friday 13th?
It's not bad. It's a superstition, and they made movies. There's movies called Friday the 13th. Part 1, 2.
You like horror movies?
They are horror movies.
Do you like horror movies? Well, things on sale today because it's Friday. I think it's a discount.
That's Black Friday.
Oh, Friday.
A different Friday.
Oh.
Yeah. I wish things were on sale today.
Friday the 13th happened.
Discounted.
I don't think I've ever
Black
been Black
Friday is
Friday.
a lot better than
I have
Friday. Black Friday is like Blessing Day, and Friday the 13th is like the Christmas.
Why Blessings Day is Black?
Yeah, I've never gone Black Friday.
Don't
What do you
buy-
say?
Why is it called Black Friday?
Yeah, but it's a good day,
I'm
right?
always
It's when everything's on sale.
either.
But why is it black?
Because it's stores, it's all about their bottom line. That's the day that they are making money. They go from being in the red to being in the black for the year. In accounting, that's what they talk about, red and black.
The black is good.
Black is good, red is bad. You don't want to be in the red because you owe money.
Oh.
That's why they call it Black Friday.
Did you know that red?
Love red. Love red.
Have you answered this problem?
I did. It's healed.
got it.
Yeah.
Actually,
I can give you a red envelope.
what does that even mean? I feel like you.
All right, so what is the equation you're writing? Justin, help me out with the equation.
The base.
Well, log.
Log. It's already there. I've already written that.
Okay.
How do I take the log out?
So the x is your number. It's like x to the 3. Yeah, no, x to the second equals 3x minus 2.
And then what do you do to solve for x?
Rearrange.
Rearrange, pull it all over. It's a quadratic.
And then
Factor.
Well, this one factor.
Yeah.
Yay, we're very happy.
X minus 2.
x equals 2 and 1.
Factor.
Nice.
Yes.
Yes.
That's a good spot to stop. We'll
Yeah.
graph some more.
Thank you. Thank you.
Keep these problems